Cosmos DB is a globally distributed database service offered on Azure. It enables turnkey global distribution. It gives guaranteed low latency at the 99th percentile worldwide. It gives high availability worldwide. It is completely schema agnostic, so you don't have to ever worry about schema or index management, and you still get your blazing fast SQL queries. And it backs up all of these capabilities with comprehensive SLAs spanning throughput, low latency at the 99th percentile, consistency, and availability guarantees. Speaking of consistency, Cosmos DB is unique in that it offers well-defined multiple consistency choices along the spectrum between linearizable consistency and eventual consistency. So you get to select the right consistency level for your app, and you get well-defined SLAs. And you know the clear trade-offs. There are many hard problems to solve to achieve those SLAs. First is that writing precise specification of the system. Second, so you know, when you're writing millions of lines of code, you must make sure that every part of the system is designed based on specifications that are rigorous. So that there is no misunderstanding of the semantics across this massive code base. Second piece is that we have exhaustive testing and verification of the entire system for consistency, for latency guarantees, for availability guarantees, and so on. But most importantly, in terms of the design choices that we have made, which were crucial to enable or guarantee these SLAs, has been that first, the entire system is fully resource governed. So from B tree to replication stack to transport to every part of the system is highly resource governed, and every component in the system lives within a fixed budget of system resources and delivers predictable performance. So designing that highly resource governed system was one hard challenge. The second piece that you know is the reason why we can give these SLAs is because we didn't build the system you know, by taking together components that were not designed to be globally distributed. In fact, we could not find components that were designed to be globally distributed, and that means a lot of properties needed to be provided. So we built an entire system which was designed from the ground up to be globally distributed. It leverages the cloud like it should in terms of you know, elasticity, how we consume and resources across clusters, within a machine, across clusters, across regions, and so on. We have used you know, a variety of verification and test methodologies to make sure that before we deploy any bits, and we do weekly deployments of the entire stack worldwide. And so before we deploy anything, all of these tests have to pass. And as a part of that, for consistency tests, we have a linearizability checker of our own. In addition, we also use Jepson and make sure that you know, it passes all the Jepson tests. We have extended Jepson in order to automate it as a part of our test infrastructure, but it's a great tool and we use it. It is a subset of SQL standard geared towards the kind of data models that we provide right now, and we're constantly evolving the SQL grammar itself. So over time, you know, as we support more and more data models, we will evolve the SQL grammar to support more and more of these SQL-like capabilities that you're familiar with from relational world. What we have done is that for a given data model, the SQL dialect we expose it stays true to that data model. So when we're adding graph operators, you know, we make sure that a developer using graph queries doesn't find you know, this language obtuse. And so we've tried to design the dialect for different data models, but we still use the same you know, familiarity of SQL and the robustness of the language. So internally we have, as you can imagine, lots and lots and lots of telemetry that we generate, and we have lots of metrics that we track. What we do is that, but many of those are very internal matrix that doesn't make much sense to developers. But everything that makes sense to developers in terms of the constructs the programming constructs that they are used to, we expose all of the corresponding matrix. So for example, different types of requests that you've issued, the sizes of requests, the status scores that you've gotten, your throughput, your latency at different percentiles, your consistency guarantees across different regions. In fact, we are going to also announce very soon PBS, probabilistic bounded staleness, as a metric directly to developers, so they can see, how eventual is eventual consistency for them if they're choosing, relaxed consistency models. So our goal is to transparently expose all the metrics so that developers can make the right decision, and they have full visibility over the system. Even though the system is fully managed, we carry the pager, we run the live site, you don't have to provision VMs or machines or deal with any of the configuration or upgrades and so on. But you still have the full visibility of exactly how your workloads are doing and how the system is performing. It is available in all regions. It's a foundational service of Azure. That means it is installed in every new region by default. It's available in sovereign clouds like China, Germany. It's available in government clouds. It's available in all regions wherever Azure is. So it's 34 plus regions or whatever. I don't remember the exact count, but yes.